Classification simply means grouping things based on similarities. This is not only essential in science, but it also plays a role in everyday life. Imagine a library where books are not classified, chaos, right? In science, as the number of known elements grew, especially in the 19th century, scientists felt the need to arrange them systematically. At first, elements were classified based on atomic weight, especially after John Dalton's atomic theory gave us a way to measure it. Now let's look at early attempts of classification. Several scientists like Dobrynin, Newlands, and later Dmitri Mendeleev tried different ways. Among them, Mendeleev's periodic table was notable. He arranged elements based on increasing atomic weight and left gaps for undiscovered elements, which was visionary. However, Mendeleev's periodic table wasn't perfect. There were defects. The position of hydrogen was uncertain. Isotopes didn't fit well because they have the same atomic number but different weights. Some elements with different properties were placed in the same group. 3 elements were placed in one box in group VIII. To overcome these, Henry Moseley came in with a better solution. He found that the atomic number, not the atomic weight, was the real key. So came the modern periodic law. The physical and chemical properties of elements are periodic functions of their atomic number. This means when elements are arranged by increasing atomic number, elements with similar properties repeat at regular intervals. So what does the modern periodic table look like? It has 18 vertical columns, called groups. It has 7 horizontal rows, called periods. Elements in the same group have similar properties. As you move across a period, the properties of elements change gradually. Now let's break down the elements. Metals located on the left side of the table. These are good conductors, shiny, malleable, and generally form positive ions by losing electrons. Small blue diamond nonmetals. Found on the right side, they are bad conductors, brittle, and form negative ions by gaining electrons. Metalloids, elements like boron, silicon, and arsenic, show properties of both metals and nonmetals and lie along a zigzag line in the periodic table. Classification of metals. Alkali metals, group Ia, like lithium, sodium, potassium, highly reactive. Alkaline earth metals, group IIa, like calcium and magnesium, reactive, but less than alkali metals. Transition metals, found in groups 3 to 12. These include iron, copper, zinc, form colored compounds. Inner transition metals, lanthanides and actinides, kept at the bottom. Poor metals, less metallic character, found in the P block. Classification of nonmetals. Halogens, group VIIa or 17. Highly reactive, form salts like fluorine, chlorine. Inert noble gases, group 0 or 18. Like helium, neon, argon, have full outer shells, making them stable and unreactive. Special cases. Hydrogen is placed in group Ia because of its 1 electron like alkali metals, but it also shows similarities with halogens. Lanthanides, elements from La 57 to Lu 71, also called rare earth metals. Actinides, elements from AC 89 to LR 103, mostly radioactive. Now let's talk about blocks. Elements are classified into 4 blocks based on where the last electron enters. S block, groups 1 and 2, last electron enters the s orbital. Example, Na sodium, K potassium. P block, groups 13 to 18, includes metals, nonmetals, metalloids. Example, B boron, Ni neon, Cl chlorine. D block, transition metals, groups 3 to 12. Example, Fe iron, Zn zinc. F block, inner transition elements, lanthanides and actinides. Example, C cerium, U uranium. Let's revise reactivity trends. Test tube reactivity of metals. Increases down a group, because it becomes easier to lose electrons due to larger atomic size. Decreases across a period, due to stronger hold of the nucleus. Test tube reactivity of nonmetals. Decreases down a group, Larger atoms find it harder to gain electrons. Increases across a period. More nuclear charge helps gain electrons more easily. Pushpin example. Potassium is more reactive than sodium. Fluorine is more reactive than chlorine. Let's answer some quick questions. Small orange diamond Q. What are groups and periods? Groups are vertical columns. Periods are horizontal rows. Small orange diamond Q. Why are group 0 elements called inert gases? Because they have full valence shells and do not react. Small orange diamond Q. What are halogens? Highly reactive nonmetals of group VIIA that form salts. Small orange diamond Q. What is a transition metal? Elements in groups 312 that show variable valency and form colored ions. Small orange diamond Q. What is an S-block element? An element whose last electron enters the S subshell, like sodium. Let's do a quick activity-style recap. White heavy checkmark, which block is carbon in? Backhand index pointing right p block. White heavy checkmark, which group does fluorine belong to? Backhand index pointing right group VIA. White heavy checkmark, which group has 0 valency? Backhand index pointing right group 0, or 18, inert gases. White heavy checkmark, which are the most reactive metals? Backhand index pointing right group IA, alkali metals. White heavy checkmark, which are the most reactive nonmetals? Backhand index pointing right group VIA, halogens. Final summary. Modern periodic table is based on atomic number, not weight. It has 7 periods and 18 groups. Elements are classified into metals, nonmetals, and metalloids. Elements are grouped into S, P, D, and F blocks based on electron configuration. Reactivity trends help us predict chemical behavior. Mendeleev's table was a great foundation, but Henry Moseley's contribution made it more scientific and accurate.